In this example, we will use the traditional method to test the claim that captopril is effective in lowering systolic blood pressure. Let's start with HO and H1. So if captopril is effective in lowering systolic blood pressure, then the second readings should be lower than the first readings. So if we take the first readings and subtract the second readings, we should end up with positive numbers. So that means the mean difference greater than 0 is the claim. For the null hypothesis, there's always an equal sign, so the mean difference is equal to 0. From the Excel sheet, we can see that the test statistic is equal to 6.371 when we have a one-tailed test and when we round to 3 decimal places. In this case, they also are giving us the critical value. They're saying that the critical value for a one-tailed test is 1.796. I, however, like to see a picture, so I'm still going to draw it out even though they gave us that information. From H1, we know we have a right-tailed test because of the greater than. Now, they did not give us a significance level, so whenever that happens, we should use 0.05. So that means we have 0.95 to the left. There were 12 pairs of data, so the degrees of freedom is 11. So the critical value, 1.796, should be right here. And you can double check that in table A3, and you do get the same number. So the test statistic 6.371 is to the right of the critical value. Since the test statistic is in the critical region, we reject the null hypothesis. So our claim is with the alternative hypothesis, and we're rejecting the null hypothesis. So there is sufficient evidence to support the claim that the mean difference is greater than 0. One more question. Is it effective? Yes, we just found sufficient evidence to support the claim that captopril is effective in lowering systolic blood pressure.